Hello guys, Ms. Cullen here, and today we're doing a video on mixed factoring on pages 44 through 46. We're going to do some of the problems together, and then the rest you're going to do by yourself as practice, and make sure you do those problems because there will be a homework quiz on this. Okay, so we're going to start off with number one. All right, and number one you should recognize as difference of squares, or dots for short. Okay, when do we have difference of squares? We have difference of squares when we can take the square root of the first term and separated by a subtraction sign, and we can take the square root of the second term. Okay, they're perfect squares. We can break this into a plus b, a minus b. Okay, so here we have perfect squares. We have 25x squared. I can take the square root of that, I can take the square root of that, and I can take the square root of that and get whole numbers. Okay, so that's how you know that you can use difference of squares. Okay, it's important that you know what your perfect squares are. Perfect squares are when I take the square root of something, I get a whole number. So for example, when I take the square root of 4, I get 2. Okay, same thing here. If we keep going up, 9, I get 3. Take the square root of 16, I get 4. Take the square root of 25, I get 5. Take the square root of 36, I get 6. 64, I get 8. So as you see, I am just listing out numbers. These are called perfect squares. Okay, these are numbers you want to look for. Okay, so here I can take the square root of 25x squared, and I can take the square root of 9. Okay, so I know this is a difference of squares, and I'm going to write it in this form. Blank plus blank times blank minus blank. Okay, so the square root of 25x squared, well, the square root of 25 is 5. The square root of x squared is just x. And then the square root of 9 is 3. So I have 5x plus 3 times 5x minus 3. Okay, you can only do that with perfect squares. All right, the next one we're going to look at is number 2. Number 2, I have a GCF here, right? That's the first step that we're looking for. What is my GCF? Well, your GCF has to say, okay, what term can I take out of all of these? It's normally your A is your smallest. So I'm going to take out, I can divide all of these by 3. So I'm going to take that 3 out, and I'm left with x squared minus 2x plus 4. Okay, because I'm dividing each of these by 3. And then I'm going to set up my x method and see if there's two numbers that multiply to 4 and add to negative 2. So we might take a minute to try some numbers out, 4 and 1, 2 and 2. Either way, you're not going to get, these numbers can't get you negative 2. They don't add to negative 2. So I have to stop here. This is as far as I can factor it, and I write this as my answer. Okay, do not forget the 3 out in front there. All right, the next one we're going to talk about is number 3. Okay, be careful. You might think, oh, difference of squares, but 12 is not a perfect square. Okay, so my first step is looking for a GCF. Now remember, GCF also has to do with variables. Okay, so I'm saying, okay, what's the biggest factor from 9 and 12? What's the biggest I can take out of x's, and what's the biggest I can take out of y's? Okay, so if we think of factors of 9, 9 and 1, 12 doesn't divide 9, so I can't take out 9. What about 3 times 3? Does 12 divide 3? Yeah, it does. So I can take out a 3 from both of them. Okay, then I have x to the fourth here, and I have x cubed here. Okay, I can't take out more than I have. I have at least 3 in both of these, right? I have 3 and then one more extra here. So I can take out x cubed. I have 2y's here, or y squared, and I have y cubed here, so I can take out y squared. I can't take out more than I have. I can't take out y cubed because I don't have that many in the second term. All right, so then I'm going to write what I have left. Well, 9 divided by 3 is 3. I took out 3 x's, so I still have 1 left. I took out 2 y's, so I still have 1 left, minus 12 divided by 3 is 4. I took out 3 x's, and so they're all gone. I took out 2 y's, so they're all gone. And that's my final answer. It's as far as I can factor it. Okay. Number 4, there's no GCF, so you can just set it up as 8 and -6 and factor it that way. Okay, remember, I'm finding two numbers that multiply to 8 and add to -6. We know 4 and 2 multiply to 8. Okay, but do those add to -6? No, in order to get to -6, they both have to be negative. And I write this as x minus 4 times x minus 2. Order doesn't matter because it's multiplying. Okay, so you're going to do a similar thing here for number 6. For number 5, be careful. People look at this and they think difference of squares because I can take the square root of 36 and the square root of 9, Miss Cullen. Correct. However, you can't take the square root of x. You only have one of them. So be careful. Okay, you can take the square root of x squared. You cannot take the square root of x. You only have one of them. All right, so instead we're going to look for a GCF. Well, I can take out 9 here and I can take out 9 here. So I'm going to take out 9. I have 1x here, I have 2 here, so I can also take out an x. What am I left with? Well, 36 divided by 9 is 4. I took out 1x, so I have 1 left. I took out a whole 9x over here, so I have minus 1. Okay, there's still that 1 there. Do not forget about that. Okay. Let's keep moving and grooving here. We're going to come down to 7 and 8. 7 and 8. Okay, so for 7, do I have a GCF? Yeah, I can divide everything by 3, Miss Cullen, right? Almost, but I can't divide that 11x by 3. Okay, so be careful. If that was a 12, yeah, I could have taken that out, but I don't have a 12 there. I can't divide those by all those by 3. Okay, so this, when we have a is greater than 1 and there's no GCF, I have to use one of my box methods. So for number 7, I'm going to show you box method 1, and then for number 8, I will show you box method 2. So for number 7, if you go back to my previous video, make sure you watch that before this. Okay, 3x squared, 11x, a, b, c. Okay, we remember I need to find two numbers that multiply to 3x squared. Well, that's only 3x and 1x, right? That's the only way to get it. Okay, but when I come to 6, I have a couple different options here. I can do 6 and 1, and then when I multiply across, the problem is 18 and 1 are not going to get me 11x. Okay, so you can always try flipping that. I can do 1 and 6, but already I know 1 and 6 kind of use, 6 and 3 will give me 9, not 11. So let's try, what about 3 times 2? Okay, once we multiply up, remember we multiply across. So 3 times 3 is 9x. X times 2 is 2x. Do these add to your bottom? Yep. Your puzzle's good. And your answer are the cross values. 3x plus 2 times x plus 3. Okay. Number 8, same thing. I do not have a GCF. I cannot take out a factor from all of these. So now I'm going to show you box method 2. Box method 2 is kind of like our original. We're going to find two numbers that multiply not to 5, but 8 times 5. Remember, A times C. So that multiply to 40 and that add to negative 22. Okay, add to B, multiply to A times C. Okay, so 4 times 10, is that going to give me negative 22? Nope. Okay, 8 and 5, nope. So you have to keep trying some things out here. Well, I don't know. What's 40 divided by 2? 20, right? 20 and 2? Yep, that'll give me it. Okay, so I know 20 and 2, but I need to stop for a second because I have a negative. So I have negative 22. It needs to multiply to positive 40 and add to negative 22, which means both of these have to be negative. Because negative times a negative is a positive. Negative minus a negative is more negative. All right, once I have that, I'm not done. I now need to create my box. That's why it's called box method 2. And in my box, I'm going to take out the GCFs. I put my first term, 8x squared, my last term, and my inner terms. Okay? Then I'm going to come here and I'm going to take the GCF out of each row. So I'm going to come here, 8x and negative 2x. I can take out a 2x. Okay, 8 divided by 2, I can do that. 2 divided by 2, and I have an x in both. What about negative 20x and 5? Well, whenever your x is negative, you want to take out that negative. So I can take out a negative 5. They both divide by 5, right? 20 divided by 5 is 4. 5 divided by 5 is 1. Cool. Now I'm going to go the other way. I'm going to take out my GCF in my columns here. So 8x squared and negative 20x. Whoa. Well, both of those divide by 4. I can take out a 4. And both of them have x's, so I can take out an x. Here, whenever you guys don't have, like I can't take out a 2, I can't take out a 5, I can't take out an x because I only have it in one term. But I do have a negative here. Either take out a 1 or a negative 1. I'm going to take out a negative 1 here because I always want the value of my x to be positive. Okay, so if you don't have anything to take out, you take out a 1 or a negative 1. So I have this as 2x minus 5 times 4x minus 1. Okay, you can also do it this method. You should get the same thing. Okay, I'm not going to force you guys to do a certain method. Some of my students say they think this method, first box method, is way easier. Some of them think that this is way easier. So whatever makes more sense to you, please do. Okay, you just need to show your work and take the steps for both of them. All right, lastly, number 9 is talking about the length of a courtyard. So here we go. Let me get a real rectangle in here for you. Okay, so I have a length of, and you don't have to draw this, sometimes it just helps, 2x plus 7, and I have a width of 3x minus 1. Okay, rectangle means opposite sides are congruent, so this is also 2x plus 7, and this is also 3x minus 1. Okay, they want to know what the area is of the courtyard. You should know the area equals length times width. Okay, so this kind of goes back to what we were doing at the beginning of the chapter. I'm going to do 2x plus 7 times 3x minus 1. All right, how do we do this? We distribute. So 2x times 3x is 6x squared. 2x times negative 1 is negative 2x. 7 times 3x is 21x. And 7 times negative 1 is negative 7. So you're going to take each term and multiply it. Okay, simplify. I have 6x squared. That just can't go with anything. I can combine negative 2x and 21x. So I have 19x. And bring down that negative 7. And that is my area. Okay. Binomial times binomial. That's what we should get. Okay, turn the page. All right, you guys should be able to do number 10. Number 11 I'm going to talk about with you. The area of the garden is 10x squared plus 17x plus 6. What are the factors? Okay, the length of the garden and the width of the garden. So we're going to factor this. So I need to find, I'm going to do box method 2 here. You can do box method 1 if you'd like, but I do not have a GCF. Okay, so and my A is greater than 1, so I know I'm going to have to do a box method. I'm going to do box method 2. You need to find two numbers that multiply not to 6, but 10 times 6, so 60, and add to 17. Okay, so you might have to think this out a little bit, right? 30 times 2, those are not going to add to 17. Okay, so maybe you do 60 divided by 3 then. Then you do 60 divided by 4, 60 divided by 5, and you keep going until you find two numbers that work. So pause for a minute, try to find those numbers. And when you do, you should get that 12 and 5, multiply to 60, and add to 17. I'm not done, okay? when you have an AC, you have to then do the box. Okay. All right, my first term is 10x squared. My last term is 6, and then I fill these in the other spots, 12x and 5x. Order doesn't matter. So I'm going to take out the GCFs of my rows first. The GCF here is 5x. The GCF here is 6. I can't take out an x because I only have an x here. Then I'm going to go this way. The GCF here, well, I have an x for sure. And both of these divide by 2, right? Right, what about here? Nothing, right? So I just take out a 1. Okay, how do I write this? Okay, well, this looks like my length, 2x plus 1 times 5x plus 6. Technically, we don't know which is the width or the length, so I would take it reversed as well as the answer. Okay, you can check your work by multiplying these and seeing if you get that. All right, number 12. They're asking me now, they're saying the volume of a figure is x cubed minus 5x squared minus 12x plus 36. Volume is length times width times height. Okay, length times width times height. They give us the length, they give us the width. They want to know what the height is. Okay, so you know that x plus 3 times x minus 6 times some height will equal this. So let's figure out what this is first, okay? So x squared minus 6x plus 3x minus 18. Let's simplify that to x squared minus 3x minus 18, okay? So I know that this times something will give me x cubed minus 5x squared minus 12x plus 36. Notice this is multiple choice for a reason, okay? I would try this out and see what you need, okay? So how I would solve this is I would say, okay, well, let me try x plus 2. What will I get if I multiply these? Remember, you have to multiply each term. So x squared times x, that's x cubed. That matches up with this so far. Good. X squared times 2x. That's 2x squared. Doesn't match up so far, but let's keep going. I'm going to take my next term. Negative 3x times x. That's negative 3x squared. Negative 3x times 2. That's negative 6x. Okay. Let's look at the squared part now. We got the x cubed. What about this? Are we going to have negative 5x squared here? Well, no, right? 2x minus 3x will give me a negative x squared. How would I get a negative 5x squared here? Well, this came from the 2, right? So I would need this to be a negative 2x squared to get my negative 5x squared, right? Would I get that if this was a 3? No, right? Because I have x squared minus 3x squared minus 9x squared. No, that wouldn't work. Would I get this if it was a negative 2? Yep, that's how I would get that negative 2 here, so it must be B. Okay, must be B. Now, you can set up a box, a 3x3 box, and solve it that way as well, but this is just kind of reasoning through it. All right, number 13, factor. What's the first thing we always do when we're factoring class? What do we look for? Good, you should be saying GCF. Okay, so I have 6, 21, and 45. I know that 21 doesn't divide by 6 or 45, but what other numbers they have in common? Well, 6 divides by 3 and 2. 21 doesn't divide by 2, but it does divide by 3. 45 doesn't divide by 2, but it does divide by 3, so I can take out a 3 in all of these. So that's what I'm going to do. Let's take out that 3, and I have 2x squared minus 7x minus 15. So I still have to use a box method because my a is greater than 1, okay? I cannot just use x method. So I'm going to show you box method number 1 now, since I did the other one last time. So I need to set up my box real quick. 2x squared goes up here, negative 7x, and negative 15. And I'm trying to find two numbers. And multiply to 2x squared, that's just 2x and 1x. That's my only options. That's why I write it in right away. Okay? What about negative 15? I have a couple different options for that. Right? I have 5 and 3 or 15 and 1. Let's try 5 and 3 first. Normally the smaller numbers are more likely. Okay, so which way though? Well, it doesn't matter. You just have to try it out and kind of see. So let's see. 5 and 3. Let's see if this works. I would have 10x and 3x. Can I get 7x somehow? Yes, but remember, don't forget your negatives. I need a negative 7x. And I have a negative 15 here. So which one of these have to be negative, the 5 or the 3? Well, if I make this negative, it would be 10 minus 3x. That would be positive 7. So it has to be my negative 5, because negative 10x plus 3x is negative 7x. Watch out for those negatives. Okay? You'll notice that I first figure out the numbers, and then I figure out the negatives. What has to be negative to make this puzzle true, to make this work? Then 5 has to be negative in order to get that negative 10, because we're going across here. Okay? Finally, for my answer, circle. Do not forget, make a big note to yourself, the GCF that you took out at the beginning. Okay, that comes out in front here. So I have 3 times x minus 5 times 2x plus 3. Okay, and we're good. All right. Number 14 and 14, we have two 14s here apparently. I want you to think of difference of squares. So for your answers, you should get blank plus blank times blank minus blank for both of these. Why? These are perfect squares. Okay, next page. You are going to do number 1 and 2 by yourself. My hint for you is GCFs. Okay, let's come down to number 3. Number 3 here should be, we're talking about a rectangular garden. Okay, the area must be 24 feet. That means my length times my width are going to equal 24. Okay, what are the possible options for the length and width of my garden? Well, there's a lot of possible options, right? I know that my length could be 6 and my width could be 4, and my area could be 24. I know that it could be 12 and it could be 2. Okay, so you find 2 more. What are 2 more options for your area of 24? We're going to use that kind of down here. Okay, it says I want to make a rectangular garden. I'm going to do number 4 with you, and I'm going to do number 6 with you. The area must be x squared plus 7x plus 10. The length of the garden is x plus 5. What is the width? Now, you can use the same reasoning as I did before and say, okay, well, I know Miss Cullen x plus 5 times blank equals x squared plus 7x plus 10. The problem with that is you don't have multiple choice here. You can't plug something in. Okay, so instead I'm going to use the box method. And I'm going to say, okay, well, what do I know here? I know that I'm going to kind of reverse what we were doing before, right? I know that if I were to factor this, and I would have x squared here and 10 here, I don't know what would be here and here, but we're reversing this, okay? So do you guys remember before, and I'm going to make this a little neater, when we used to multiply by saying, okay, x plus 5 times blank plus blank, and then we would multiply this way. Remember how we used to do that? Okay, we're going to kind of reverse that here. We're saying, okay, I know that x plus 5 times something up here will give me this x squared plus 7x plus 10. Now I know there's going to be two numbers here that I don't know yet. That's kind of what I'm looking for. Okay, then to pull that out of my GCF. Okay, so we're going to reverse our thinking here. We're saying, okay, well, I know that x times something will give me x squared. What's the only way to get x squared? This is going to have to be x, right? X times x is x squared, okay? Which means if I follow this pattern, what's 5 times x? Well, that's 5x, right? And what does this number have to be in order to get 10 over here? Well, that has to be 2, right? 5 times 2 is 10, okay? Which means 2 times x is 2x. Remember how we used that before? Does 2x plus 5x equal 7x? Yep, I did this right. So what is my missing side here? It must be x plus 2. Okay, that might be a little bit confusing, so I am going to do another one with you. Okay, so for I'm going to help you set up number 5 actually a little bit, and then I'm going to talk about number 6. So number 5, they're saying that the area of your garden, so I'm going to set this up the same way. I know that x minus 7 times something will give me this. So how do I get x squared? Once again, well, this also has to be x. Um, and then I'm just going to multiply. Well, negative 7 times x, that's negative 7x. I'm trying to get a negative 3x here, so you can think of it that way too. How would I get a negative 3? Well, this must be 4x, right? It's negative 7x plus 4x, okay? Which means this must be 4, because 4 times x is 4. 4 times negative 7 is negative 28. So does your puzzle work? Yep, this must be x plus 4. Okay, for number 6, I want to make a rectangular garden. The area is this. Find the length and the width this time. Okay, so here I can just factor it. Once again, they're just kind of asking me for the factors. Okay, so I'm going to, the A is 1, so I can just simply do this. What are two numbers? I multiply to 35 and add to 12. Okay, now you can set this up like this in a way, but you don't know what those two numbers here are going to be to get you 12x. So I would just factor it this way. Okay, and the two numbers that multiply to 35 and add to 12 are 5 and 7. So I know that it doesn't matter which is which, x plus 7, x plus 5, or vice versa. Okay, I hope that helped you guys to get started on this video, and I hope you guys have a great day.